Did anybody participate in the Boy Scout varsity triathlon this last weekend? This triathlon in Pima?
No.
You just missed on some. What's that?
I got a one.
Oh, that's good. Yeah, the triathlon actually is named after my dad.
Oh, really?
Yeah, it was started 25 years ago by my dad for the Boy Scouts to have something to do here that was competitive. Anyways, ever since it got named after my dad, we've been doing it as a family. I think the unspoken rule is you're not supposed to train for it. You're supposed to go and just get murdered. Because we want to see who sucks the worst. That's actually the one way to win.
Oh,
Me and my family. So, anyways, I was gonna. Whoever did it, if anybody did it, I was gonna give you extra credit. Even though it says Varsity Scout Triathlon, it's actually open to the public, and they had like 16 plus, like 1675 people do it this year.
The largest in the nation.
It is the largest in the nation.
Wow.
So, and it's kind of cool. Something my dad started and 25 years ago. I was in the very first one ever. There was like 16 of us.
I knew your dad. He was a good guy.
And they, I was like 9 years old. And he said, "Hey," I woke up that morning. He's like, "Get up." I'm like, "What? You're doing a triathlon today." A triathlon what? I was like 9 years old. I remember coming out of the pool like dying and hearing all these people go, "Oh my gosh, that guy's so little." So, anyways, take that how you want.
I heard the pool was pretty good this year, but it's actually pretty warm too.
Are you being sarcastic?
No, really. I have friends that do, 'cause see, I can swim, but I hate cold water.
Oh, I was in the early heat, so it was still kind of overcast.
Okay.
And when I caught it, jumped in, it was like, it's
My
cold.
girlfriends that did it, they're like, yeah, it was actually better than it's been. So, yeah.
It must have been smells of summer, wet in the afternoon, because it was cold. It was 54 degrees, the water.
Oh, that's a little
that hurts.
They took a temp of it.
Maybe the breeze had died down or something.
That's a little cold.
And
A
then,
couple years ago when they had during that big storm.
oh yeah,
the rain
it was
and the
freezing.
wind
So is it bicycle or?
So you swim 75 yards, bike 6 miles, and run 1.6.
Yeah, that 1.6 would be a little tough. Biking, not so much.
I used to be able to do
Yeah.
it. A year ago, I could have done
and
5.
Not that great.
My knees are too good.
Yeah.
Like 5 miles?
I used to get.
You bike 6 miles.
You bike 6 miles?
Yeah.
So that's the only reason we do it is because it's a short triathlon, so we can survive it. Okay, so before I get started on the PowerPoint, anybody have questions about chapter 23? I will tell you the most common mistake on the math so far. Very common, is people are dragging in the total supply into their math. So if I give you an order that says, I have an order for 7,500 units, and you have a vial that's 10,000 units per ml with a total supply of 5 mLs in that vial, what's important for the math?
The 7,500 over 10,000.
7,500 over the 10,000, right? Not the 5 mLs, because that's getting added on the end of the math problem and people are getting it wrong. So make sure that you only pay attention to the concentration. The total supply doesn't matter unless I'm telling you how many vials will this take. Then you need to figure out, okay, how many mLs are in a vial? This is how many vials I'll need. Okay? But otherwise, the total supply is just distracting information. Just like if you were looking at the label on the vial and on the top it says 10 mLs in the right corner, that does not include it in your math unless I'm trying to figure out how many vials I'll need. Okay? So just make sure you don't get caught up in that. Very common. I've had multiple people have to get their assignments back with missing points because of that. So make sure you pay attention to that, okay? Any other questions? Yes.
Are you available for help in your office?
I'm available in my office. Today I'll be there from 3 to 5. Tomorrow I'll be there from 2 to 4. Thursday I'm there. I work Airback Wednesday night, so Thursday I'll get there
You get there around 10.
around 10, and I'm there from 10 to noon, and then I teach from 1 to 3, and then I'm in my office from 3 to 4. On Thursday I don't have official office hours, but that doesn't mean that you can't swing by. Does that make sense?
So Thursday, 10 to 12, and 3 to 4?
So, yes.
There is a problem, I guess I can't understand, but it's on the 21-22 test. It's the last one, it has 2 parts.
Uh-huh.
To try and find out like the rate and then the percent, but I couldn't find out like how many hours you had left. It's like it was running from 7 to 11, but it didn't say how long it was supposed to run for, so I was just confused on
On the 21-22 test,
yeah.
I will look on yours then. Is that video me button not work? Let's look real quick. I'm in web study. 21-22 tests for Samantha. Oh, the 21-22 test that's in this
Yeah,
module.
yeah.
No wonder you're the only person that has a question on it, because you're the only person that's jumped up and done it so far.
I'm gonna get ahead to
Yeah.
my final week. It's the test for tomorrow.
Because I didn't give you guys a test during Easter week,
Oh, yeah, that's
I
right.
didn't do too well on that.
so I threw it onto this module.
These are what these are.
Okay, let's see here. Is it a regular? Let's see.
It's the very last one.
The very last one?
Yeah,
Oh, the one that you typed out specifically
Yeah.
that you wanted me to help you with it.
yeah, that's what
Okay.
I do. I'm like, I get that.
Okay. Okay, so the percentage change in IV rate,
That comes,
hold up. Just want to confuse. Okay, so it is assumed that 125 mLs an hour is going to infuse that at 8 hours.
Okay, I just didn't know like
So
the 8 hours.
the 8 hours would have helped you out. I'll go in there and actually spell that out specifically. It just says 1,000 mLs is supposed to infuse at 125 mLs an hour, meaning 8 hours for the liter, and it should have that in there. So I will add that in there. Okay, and then that'll make your life a lot easier for doing that. Write that down. 21-22 test. And I'll go in there and change that today, so everybody else can learn. I mean, can succeed from your finding that for me. Okay. All right. Any other questions?
How are we doing?
You guys, I think, are doing pretty good. You guys, that's the cool thing about web study. You guys always have an up-to-date grade book. If you'll let me get in there. The only people that are not passing this class are people that have dropped, aka everybody's passing for this section. I don't want anybody online. Online's like, oh yay, I don't have to do anything more. Okay, so divulge everybody's grades. Okay. Okay, so just remember the final can be done in class at the specified final time for this class period, or it can be done online, whatever you want to do. okay?
You said it was Monday, May 4th, or Wednesday,
The 6th,
the 6th.
okay?
From 1 to 4.
How much time do we?
What time?
You
on
get
the
2
6th?
hours, whether you do it online or you do it in the classroom.
What time on the 6th?
11 to 1.
11 to 1. I'll tell you, one of the bonuses of doing it in the classroom is this right here. Mr. Brinkerhoff, I have a question on number 13. And then I can go like, oh, you might want to do, okay? That's the bonus of doing it in the classroom. And if you like writing, I prefer writing it over typing it because I can see it on one big thing of what my, because I write it differently than I type it. So, personally, the way I do the math for me, I teach you guys how the book does it, and I use a lot of the dimensional analysis myself, but some things I do just a little bit different sometimes. So, just from 8 years of doing it.
Yeah, I was just gonna say half a year's memorized.
Yeah.
So there's no way we can take it earlier in person?
No, if you need to take it earlier, and because it is a strict policy of the college that if I allow
Like time, not date. Nice.
Like earlier on Monday, May 4th,
Because I work at 11.
you can make arrangements with me to take the file anytime in my office between Monday the 4th and Thursday the 8th. But I will not give it any earlier than the 4th because the dean, I have to get dean approval to allow dean approval per student to allow any test taking, and I'll tell you right now, 99.9% of the time it's a no. Especially since you guys have it available to you online to take it online. So, okay. All right. These are the fun this is the fun chapter. This is some of the funnest math there is right here. This is what I'll tell you why it's my favorite, because it's the critical care math. This is the stuff that we use in the ICU all the time. So, in this, we're going to do micrograms per minute, micrograms per hour, milligrams per minute, all kinds of different weight-based and milligram and microgram-based math. So, the reason why we it's important to know your critical care math is critical care medications can drastically change vital parameters such as blood pressure and pulse. That is the primary reason why we give critical care drips, is because this is like, when we think of life support, oh, they're really bad, they're on life support in the hospital. We think of just breathing machines. That's because of respiratory failure. You can have other symptoms of failure that can require life support, and our life support is in the version of drips, okay? And that's where we can artificially change parameters to keep you alive, okay? And so a lot of them that we use in the hospital setting change primarily blood pressure and pulse. So we do titrations, and that's when we will change the specific rate or dose based on the patient's parameters. So if I have a patient that's on 10 mics of levofed, which is a blood pressure medication to keep it high, and they still are hypotensive or low, then I'll increase my levofed, and I'll have to redo the math quickly to make sure that I have the new dose correct and the new mLs per hour, and then I can change my rate to change their blood pressure. Okay, so very important, especially if you're thinking of doing intensive care. I've had patients where I've had 3 quad pumps running with 12 total drips at a time, all titrating different parts of the patient's vital sign parameters. So that patient was a super sick patient. It was during the swine flu season. I haven't had a patient like that in a while. I've had a couple in between, but that was one of the sickest I've ever had. It was from the swine flu. So it just kind of gives you an idea what you can be up against and why it's good to know your math. So, for critical drips, make sure you understand that 99% of the time, you need to use a pump. Actually, you should shoot for all of the time you use a pump. But every blue moon, and it's happened to me flying in the helicopter, I've had patients on critical drips, and our helicopter pump decides it wants to quit. And so then we have to start doing some drips per minute math really quick to titrate at those same rates to maintain the patient's vital signs. So, it's only happened to me twice. I hope it doesn't happen again, because every time it's a really, really, what we call a puckering situation. So, anyways, infusion pumps are the best. Infusion pumps nowadays, they will also do the math for you, but it's still required for you to do the math to check the pump. Because there is a portion that can cause errors when putting stuff into the pump, and that's the person putting it in, okay, right? Because every once in a while you'll hit a wrong button or do something and you're like, hey, that doesn't match my math. And you look and you're like, oh, I pushed the wrong buttons, and you go on and change it, okay? So very important. So like, something that you might see when it comes to orders and critical drips would be something like this. Titrate nitride to keep blood pressure at 140 millimeters, starting at 3 mics per kilo per minute. Something that is usually part of that order also will include a range. Titrate levophed between 0 to 20 mics per minute to maintain systolic blood pressure of 90. That's another one that you might see, okay? So that way you're covered for titrations per order, because if they just said, hey, start levophed at 5 mics per minute for, then you're stuck. Because if you need to titrate, then you have to call, hey, my patient's systolic blood pressure is 70 right now. Can I titrate to 10? Yes, you can titrate to 10. Does he want to be bugged all night long? No. And there's sometimes that we're titrating 4 or 5 times in an hour. Up and down, up and down, up and down, based on patient status. If I didn't have a titrate order, then I would be waking up my doctor 4 to 5 times an hour all night long. They usually are pretty grumpy in the morning if you do that, if you're wondering. So,
Don't be one of those grumpy doctors.
I will not be a grumpy doctor unless you're a dumb nurse. That's all I have to say. I'm just kidding. I'm just messing. I'm a nurse right now. I would never do that. But I do, I'll be honest with you, a little side note, I do kind of fear for some of those nurses that are lazy, because when I catch lip back, I'll be like, hey, I've done your job, don't give me that. And they'll be like, oh. My poor wife, see, I worked at Banner Desert, and we would have patients on drips and everything like that, and be doing electrolyte replacement protocols. And so when they tried to institute that here in Safford, she'd be like, oh, what are they supposed to do? They're just so busy, blah, 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 blah. And I'd be like, blah, blah, blah. She's like, I never get any sympathy from you. I'm going to stop telling you things. So, yeah, I'm a horrible person. If I've had to deal with it before, your chances of sympathy are very slim. So, calculating rate in mLs per hour for a specific dosage is one of the most common calculation a nurse encounters. Before, when I first started, we had pumps that all you could do is put in mLs per hour, meaning we had to do our own math. So back in the day, just after they put cement on floors, we upgraded from dirt. We would have to put our own mLs in and not have to do math for every single titration. So here's an example: a solution of labetalol, 100 milligrams per 100 mLs of D5Ws to infuse at a rate of 25 milligrams per hour. Calculate the rate to infuse the solution in mLs per hour. So, right off the bat, I'll tell you a trick.
It's 1 to 1.
If it's a 1-to-1, guess what your mLs per hour would be? If it's a 25 milligram per hour and it's 1 milligram per ml, guess what my mLs per hour is going to be? 25 mLs per hour. Right? So the 1-to-1 solutions are actually pretty easy. There's a couple drips that we use. Labetalol is one of them. Another one is cardizem or diltiazem. We use for AFib with RVR. That's another one that comes in a 1-to-1 solution. Another one for insulin drips, we use 1-to-1 solution, 1 unit per ml solution for insulin drips. So the math for those are pretty easy. And the other one is that we use that's pretty close is 25,000 units in 250, and that's for heparin. So that makes math pretty easy because that's what is that? 100 to 1, 1,000 to 1.
100 to 1.
It's 1,000 to 1, isn't it? I don't know. Either way, I know that it's pretty easy to do the math. So I have to actually remember do the math. So ratio proportion, you can do it this way, and like I said, any way that gets you the right answer every time is okay by me, as long as you can show the work. That's it. So if ratio proportion works for you, that would be 100 milligrams for 100 mLs, 25 milligrams for how many mLs, and that will get you your 25 mLs per hour. You just have to remember, when you use ratio and proportion, the time component is not a part of your math. Okay, so you have to add that on. So that's an easy for a 1-to-1, or anything that's already in that dosage per hour. So it was in milligrams per hour, and we were making it easy by doing milliliters per hour, but if I was in milligrams per minute, trying to go to milliliters per hour, that's a little more complicated math, and that's when dimensional analysis works the best. So, isopril, 2 milligrams for 250 mLs infused at 5 micrograms per minute. So let's do this using dimensional analysis, and I'll do it on the board with the fancy dot cam. Let me just write down my numbers here before I switch over. All right.
You're a little zoomed in.
There he is.
Honey, brains, bones.
Okay. So we have 202 milligrams. I'll try to write with better handwriting. Per 250 mLs. And we need to go to micrograms first, right? So 1 milligram equals 1,000 micrograms. So what's on top?
Milligrams.
Now we have micrograms on top. We have micrograms per ml. We need micrograms per minute, right? So I need 5 micrograms per 1 minute. Now we've added in a time component. I got that wrong. 2 seconds.
Or do we need to do that hour? The 1 minute, 1 hour thing? Or 60 minute 1 hour?
But that won't give him micrograms on the bottom.
You're right, Justin. I apologize. I'm on the spot here and I'm doing it wrong. We need milliliters per hour, right? Okay, so I need milliliters to cancel.
Which they have.
OMG, I apologize. Who am I? We start with our order. 5 micrograms per 1 minute. Everybody erase everything you just did and learned. Okay, now let's start over.
Okay.
Oh, I was like, stumped the teacher moment. Holy moly. Okay, 5 micrograms per minute. I was like, where's the time component? Why is it not helping me here? So 5 micrograms per minute. We got to start with our order. Okay, now I have
Times 60.
1,000 micrograms and 1 milligram,
Times 60 minutes.
because I'm going to have 2 milligrams for 250 mLs. So now my micrograms have canceled out. Now I have milliliters per minute. That was a close call. 60 minutes and 1 hour. That's why we do dimensional analysis, because we can tell right away, hey, something's not adding up here. So if we look, what are my units left? Milliliters per hour. So have I set it up right, finally? Oh my gosh, that was embarrassing. If you could see me right now, you could see my red face. 5 times 250 times 60 equals, divided by 1,000, divided by 2. 37.5 mLs per hour. Okay, is that 37.5 mLs per hour okay?
Yes.
Yes, because our infusion pumps will titrate to the 10th ml per hour. Okay. So we figured this out. If you notice something, though, remember we were talking about ratio and proportion, and when you have a time component, it's not the best thing to use. If you notice here, they had to do ratio and proportion 3 times to get the final answer. When we put it all in the same dimensional analysis problem. Okay, so that's why I prefer dimensional analysis for any rate problem. Okay, so 38 mLs per hour is what they rounded it to, but for IV pumps, we can do it to the 10th. So if you get an answer that's to the 100th, what should you round it to? The 10th or 1 decimal place, right? Okay, here's another one. 400 milligrams and 500 is our concentration. And this is dopamine, right? We're to infuse at 30 mLs per hour. Uh-oh. What's our micrograms per minute and micrograms per hour? Okay. So, every once in a while when I'm flying and I go pick up a patient from another facility to take them to a higher facility of care, and they've started a critical drip prior to us getting there, a lot of times that's when I have to do this math to figure out, okay, what are they running this at? Like, because every once in a while, especially if it's a smaller facility, they're like, oh, and we started dopamine at 10 mLs per hour. And you're like, oh, do you know what the dose is? They're like, oh, there's a dose. And you're like, oh, yes, there is. Don't worry about it. As long as your patient's fine, I'll figure it out. Let's go. So every once in a while that happens. So it happens all over, not just, don't think I'm trying to call out anybody. But, so we have 400 milligrams. This is our concentration dopamine. 400 milligrams for 500 mLs at 30 mLs per hour. We need to find out micrograms per minute and micrograms per hour. Okay?
Or zoom out a little bit.
There you go.
Let me move it up because this looks better on the
Oh, okay.
because I can see what I'm recording here in front of me. So,
Okay.
thanks for being picky. Okay, appreciate that. Okay, so we're gonna start with what we're ordered at, right? We're gonna get that right this time. I'm not gonna skedaddle. What's the word? Tittle tattle. What's the wasting time?
Dilly-dally.
Dilly dally. I knew it was one of those. Dippity doo. I don't know. I guess I'm not that old. So we started at 30 mLs per hour. That was our ordered rate, right? Okay. Now we're going to start with our concentration first. What needs to go on the bottom?
500 mLs
Why?
to cancel out the amounts.
Good. With 400 milligrams on top. So now we're in what? Milligrams per hour. But we need to keep going. Okay, so what's next?
You need the micrograms, right? Or micrograms per minute.
Micrograms per minute, or what are we already in?
Or we're already in hours.
We're already in hours for time, so let's go for micrograms per hour first.
Okay.
Guys, we're already. Oh, never mind.
Okay, so I'm in milligrams right now, so I need to be in micrograms. So what's going to be on the bottom here?
Milligrams.
What's going to be on top? Okay, so I am in now micrograms per hour. So let's do that math because that's one of the questions. 30 times 400 times 1,000 divided by 500. Is that right? 30 times 400 times 1,000 equals divided by 500. So 24,000 micrograms per hour.
That makes sense, cause micrograms are tiny.
Because what are we running at?
30 mLs.
What's 30 mLs of 400? If you have a concentration of 400 divided by 500, I'm just doing some math really quick, times 30. Yeah, that's 24 milligrams an hour. That's what I thought. I just checking my math. Okay, so 24,000 micrograms per hour.
Divided by 60.
You can divide it by 60, but I'm going to write it out again just so we can practice this. 30 mLs per hour times 400 milligrams per 500 mLs times 1,000 micrograms per 1 milligram times 1 hour equals 60 minutes. mLs, milligrams, leaving micrograms, hours, leaving minutes. Okay, so now we're in micrograms per minute. So 24,000 divided by 60, 400 micrograms per minute.
Do you want paper?
I brought an extra paper,
Oh,
and I'm using your paper.
24,000.
I brought one, and I thought I had, that's what I had in front of me, and then I realized I was writing on your paper, so.
Oh, I have some more.
Okay. Pronestal, 60 mLs an hour. The solution is available as 2 grams and 500 mLs. Calculate the milligrams per hour and milligrams per minute that the client will receive. Thank you. So, what we need to write down,
60 mLs per hour.
so we're going to write down, first I always like to write down the concentration, so 2 grams and 500 mLs. And it's at 60 mLs per hour. And what do I want to know? How many milligrams per minute and milligrams per hour. I'm gonna raise this up for Rebecca in the back. So that looks like a 25. That's because I have horrible handwriting. So 2 grams and 500 mLs, 60 mLs an hour. How many milligrams per minute and how many milligrams per hour?
so 60 milligrams
So 60 mLs
an hour.
per 1 hour.
2 grams over 500 mLs.
Right.
And then you gotta make grams into micrograms.
So
So-
you gotta like multiply your 500.
It'd be 10,000, wouldn't it?
So 1 gram equals 1,000 milligrams.
Oh, yeah, so we can-
1 milligram equals 1,000. But we're only going to milligrams. We're going to micrograms, so that doesn't matter. We can just go to milligrams. I started to go to micrograms. Got carried away. That's 1 million.
Thought we had to.
Okay.
Don't we have to?
Milligram per minute, milligrams per hour is all we're going to.
Oh, no, it says 2
So,
grams.
so right now I'm at milligrams per hour, right?
Yeah,
Don't pay any attention to that business. Okay.
times,
So
no, we're done.
60 times 2 times 1,000 equals, divided by 500 equals 240 milligrams per hour, right? Milligrams per hour.
Yeah.
Okay, let's do milligrams per minute. 60 mLs per 1 hour. 2 grams per 500 mLs. 1,000 milligrams per 1 gram. Good so far, milligrams per hour. Now we need milligrams per minute, so 1 hour equals 60 minutes. So now I have minutes. And milligrams per minute, we're good for math. We're good, go for launch. 60 times 2, if I could do this math, 60 times 2 times 1,000 divided by 500 divided by 60.
Milligrams per minute.
4 milligrams per minute.
Close enough to minute.
That minute almost feels like an hour, but it's not. It's not. It's just horrible handwriting.
It says minute.
So 4 milligrams per minute. Okay? Okay, so that seems easy enough, right? Until we add something else.
Wait.
A weight portion to it. So actually dopamine primarily, when we were talking about, we were infusing at 400 micrograms per minute, is primarily given in a micrograms per kilogram per minute. So it changes it up a little bit. Now we're adding a weight component to it. So calculate the dosage based on micrograms per kilogram per minute. Okay, so here's our order. Dopamine, 2 mics per kilo per minute. Available solution is 400 milligrams and 250 mLs. And the client weighs 150 pounds. Okay, let's write this stuff down. So my order is 2 micrograms per kilogram per minute. My available is 400 milligrams per 250 mLs, and my patient weight 150 pounds. Oh boy.
Okay, so can we flip back so we can see you?
Okay. Order 2 mics per kilo per minute. Available 400 milligrams per 250 mLs, and the weight is 150 pounds. So first things first, what do we got to do?
Available 400 milligrams per
Pounds.
pounds to kilograms. That makes sense.
68.18 continued.
$150 divided by 2.2. 68.1818181818181818. So what is that to the tenths?
68.2.
Kilograms, right? 2 micrograms per kilograms per minute. 2 times 68.2, 136.4 micrograms per minute. So there is my new dose, okay, based off of the weight. Does that make sense? Because we can't do 3 components with dimensional analysis, right? We could add that in as a factor, the weight later, but that's a way complicated addition. I did that last semester and it lost so many people. So, just right off the bat, figure out what your weight is in kilograms, and then 2 mics per kilo per minute, and just plug that in there like I did here. So 2 mics per kilo per minute, that's my patient weight in kilograms. 68 times 2, so then that combines these, making it 136.4 micrograms per minute. That's what the actual dose is based off the patient weight. Okay, so now we can do our math. 136.4 micrograms per minute what needs to be on bottom here?
Micrograms. The 2 micrograms. Oh.
Then what?
400 milligrams.
So micrograms, milligrams. What am I in now? mLs per minute. Is that right? What does my pump know?
No, you don't have the minutes yet.
My pump knows hours, right? So I got to convert this to hours now. I do have minutes, 'cause that's what I started with.
Okay,
So I need to go to hours. So 60 minutes equals 1 hour. Minutes cancel. So guess what I'm left with now? mLs per hour.
Right.
Is that something that my pump will now understand?
Yes.
So 136.4 times 250 times 60 equals, divided by 1,000 divided by 400 equals, no, 136.4 times 250 times 60 divided by 1,000 divided by 400. There we go. 5.1 mLs per hour. Getting itchy on me?
Something bit me or something. It just keeps going like this and shocking me.
Okay. How's everybody feeling so far? Do some more?
Mm-hmm. Please.
Real quick.
He's got other.
Just make sure you understand that when we titrate,
Still has some more.
what's that?
She was giving you another paper.
Oh, is it still up on the, it's not going to PC?
No.
That was weird. Okay, so just remember with titrations, the whole idea is to keep a goal that is set to you by a doctor's order. Usually it's some sort of vital parameter, whether it be pulse rate or blood pressure. Whether you're titrating to keep the blood pressure up or whether you're titrating to keep the blood pressure down, because sometimes we have those cases too with different medications. Okay? And you understand that titrations mean it's not a set dose. You're supposed to increase and decrease as necessary based off of the vital signs or parameters that you're given. Okay? But there are some medications that we have dosage ranges. So like dopamine. Dopamine has a dosage range of 20 micrograms per kilo per minute. Okay? Once I've exceeded 20 micrograms per kilo per minute, if I'm still not reaching those vital parameters, then it's time to add another medication up. So then we would add like Levophed. Okay? Levophed is another medication, but it works on different receptors. So that way I can still get the vasoclamping that I would need from the situation. So I would add Levophed. Let's say I have 20 mics of dopamine. Now I'm going to add Levophed, and the dosage range for Levophed is 0 mics per minute. There's no weight based on that. 0 to 20. So I get to 20 mics per minute, and now I'm at my dosage range, my limit. Guess what? I'm not going to go any higher. I'm going to add another medication, okay? Probably Epi. And then I would go from there and there and there and there, okay? So, based on your patient, just make sure that you understand that once you hit the top end of the dose range, don't just keep going, okay? You've already started to max out all the receptors that that medication is working on, so it's time to switch because you're just doing more harm than good at that point, okay? I've seen patients that we have overdone it with these vasopressors and made it so like we're shooting for a blood pressure of 120/80, which for a patient on pressors is not a good idea. That's normal, isn't it?
Yeah.
We want them on the low side of normal, so we always shoot for 90, okay? And so we've had patients where the nurse not knowing titrates their medication so they get a nice blood pressure of 120/80, and you look at the patient and they just look like crap, right? They're all pale, cool, clammy, and then you're like, whoa, 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 and you back off the medication to where there's systolics in the 90s and they pink up, their pulse starts to feel better, and all these things start to look better for the patient. So just remember with these pressors, it's easy to overdo it, okay? Okay, so let's go ahead and figure out this flow rate. right? Everybody see that? Nipride to titrate from 3 to 6 micrograms per kilogram per minute. Blood pressure between below 140. That's not really important to our calculations. But what is 50 milligrams available? 50 milligrams. Man, my handwriting's horrible. I can't even read my own handwriting. 50 milligrams in 250 mLs. Okay, and the patient weight 56 kilograms. All right. You know why it has it in kilograms already for us? Because they're being nice, because we actually have to figure out a dosage range, so we have to do some extra math. So what do we got to do first? Let's figure out our dosage range.
168 to 336.
Okay, we got 160 at 336, but I'm going to show the math for that really quick. 3 micrograms per kilogram per minute equals, what'd you say?
168.
168, is that an exact number?
Yes, it is.
Micrograms per minute. And then I have 6 micrograms per, what was the other one?
336.
I guess I could have doubled it. Might have been easy. So that is my dosage range, 168 to 336 micrograms per minute, based off of the weight of the patient, right? So let's do some math. 168 micrograms per minute times, I need it in milligrams first, right? Okay, so now I'm in milligrams per minute. So I can do some conversions here, because what am I going to put on the bottom? Did I say 50 milligrams, right?
Yeah.
50 milligrams and 250 mLs. So mLs per minute, but my pump reads in mLs per hour, so what do we got to have? 60 minutes and 1 hour. With minutes canceling out, so now I'm in milliliters per hour. Guess what? My pump will work now. So 168 times 250 times 60 divided by 1000 divided by 50. 50.4 mLs per hour. Okay? You need to figure out the top end of the range now.
So wouldn't you just be able to double
You could
that?
double it, but I'm going to show the math for it. $336 times 250 times 60 divided by
You should have 1,000.
1000 divided by 50 equals 100.8 mLs per hour. That's 1000 micrograms in 1 milligram there.
Okay, so you're telling us that dependent on their blood pressure, because
Mhm.
that's what it was, right? It was
Mhm.
an EP, yeah. Then we can get or change a dosage anywhere from 50
to 100 mLs per hour. So let's say my patient's sitting there, he's been sitting at 140 systolic per the order for 6 hours. So I haven't had to change my dose here at 50 mLs an hour, right? I haven't had to change the IV rate. But now he's starting to climb up. I pissed him off because I told him he's gonna have to stay an extra day, right? So now his blood pressure is 165. So I gotta titrate my medication up. So I like titrate at 75 mLs an hour. Okay. Am I still on my dosage range? Yes.
Yes.
Am I going to be taking blood pressures? Yes, because I'm messing with medications that actually mess with his blood pressure. So I take some blood pressure medications, and he's like 155 systolic now. So I'm like, oh man, I guess I better bump it up a little again. So I go to 80 mLs an hour just to see what happens. And I can titrate like that until I reach my max or my patient goal.
Right.
Okay. So I titrate him. I'm like, I'm running out of room here. So I go to 90, and then he comes down to 140 systolic again. Okay. And now he's starting to creep down. Now that I've got him calmed down, now he's 130 systolic. Okay, I'm going to take him out if I don't watch it. So now I can decrease my rate.
Back to 75.
And then I'll keep decreasing
down
until I get back to my goal of keeping him around between 130 and 140.
Okay,
Okay?
okay. But you wouldn't go over 100.8
Right.
without another medication.
Exactly. If I got to my limit, order limit, I would call the doctor and say, hey, I'm at my order limit. I'm at 6 micrograms per kilo per minute right now. And he would say, okay, I'll let you go to 8 for this many hours. If that doesn't work, then you're going to give this medication as a one-time dose or something like that.
Okay.
Okay? What if I was using micro drip tubing? What would be my drips per minute? Micro drip is 60 drops per ml. So if I wanted to get 50 mLs per hour with micro drip tubing, I would have 50 drops per minute. Remember, micro drip, whatever your mLs per hour is your drips per minute. If it says micro drip, okay? So if I wanted to titrate at 100 mLs an hour, then I would do 100 drips per minute, okay? With micro drip only. If it says micro drip, that means that your mLs per hour matches your drips per minute, okay? Okay. mLs per hour equals drips per minute with micro drip tubing. We want to do another one? We've been hammering these out. I'll do another one if we need to. Or do you guys want to go home and try it some more? Do some from the book before you do your homework? The homework's between 23 and 25, so I recommend doing practice from the book.
Let's do some more because
Let's
the
do it.
book sometimes is confusing the way they do everything.
Well, what I would recommend is using the book for problems,
Yeah, that's fine.
but doing it the way you're taught, like you know how. So, otherwise, because if you try to, you know, let's see here, 24. Let's get there. That song gets stuck in my head for months at a time.
Let's see.
Oh, I got one. I'm just gonna make it up on the fly. Okay, so I was gonna use this today. I have a patient. This is real live patient stuff right here. Hopefully, it makes it a little more interesting. Comes into the ER with chest pain. Okay, and we put him on the monitor, and he's going in and out of a rhythm called VTAC. Ventricular tachycardia. Okay, so this patient's in ventricular tachycardia in and out. Okay, one of the times he decides that he wants to stay in ventricular tachycardia and goes unconscious. Okay, so then we start what we call a code or a code blue. And we start CPR and compressions while we get the thing hooked up to him. We hook up the monitor to him and we shock him, zap him. We get him back for just a normal rhythm for just a short time before he goes into that ventricular tachycardia again. Okay, so we keep doing CPR, charge the thing up, do ACLS protocols as designed, and we shock him again. Okay, so now we have him in a normal rhythm. Okay, and then he goes right back into ventricular tachycardia again. Okay, so normal protocols is we would shock him, but we would prepare a medication. The medication is called amiodarone. Okay, and we usually give it in 300 milligram doses if they're dead. Okay, so if they're dead, 300 milligrams. So we can, if they're dead, meaning no pulse, we can give it IV push. Okay, how many vials am I going to give this patient if the vials, if I have 150 milligrams per 3 mLs?
150, say it again, milligrams
That'll only be 2
per
hours.
3 mLs.
Okay,
Right.
so I have two, I'm going to be giving this patient 2 vials. Okay, you understand why the math's important so far. So I'm going to be giving this patient 2 vials. So I give 2 vials IV push, he starts to come around, and then he does it again, but only for a short time before he goes back to normal sinus rhythm. Okay, so our protocol states we probably should give another dose so he doesn't go back and stay in this rhythm, but he's completely unconscious right now. We're doing all kinds of other things, so we need to hang a drip. Okay, to start a drip, we have to hang. We do a bolus dose first of 150 milligrams in 100 cc's or mLs over 10 minutes. How fast do I set my mLs per hour?
Say it again.
150 milligrams.
So the order is
Yeah, I need the order, thank you.
150 milligrams in 10 minutes. Available 150 milligrams in 100 mLs.
So 150 milligrams.
Say it again.
So 150 milligrams over 10 minutes. 60 minutes equals 1 hour. So now I'm in milligrams per hour.
So we're trying to find drips per, or how much, what are we trying to?
We're trying to figure out how many mLs per hour do I set my pump to give that bolus dose over 10 minutes.
100 mLs is gonna go on the bottom, and 150 milligrams is gonna go on the bottom. No, I did it wrong, backwards.
100 mLs goes on top.
100 mLs goes on top.
And then
That's it.
once.
Because we only need 10 minutes, we need it to go to 10 minutes.
150 milligrams over 10 minutes. 60 minutes over 1 hour. 100 mLs over 150 milligrams. So my 150 milligrams and 150 milligrams cancel out. My minutes cancel out.
And we're left with mLs per hour.
mLs per hour.
And you're left with your mLs per hour.
Okay.
So 60 times 100 divided by 10.
You left out the
You left something out.
150.
You left out the
You
150.
forgot the
No, I
150.
didn't. The 150 on the bottom and the 150 on top cancel each other out completely.
Oh,
Because 150 divided by 1.
So my mLs per hour on the pump will be 600 mLs per hour to infuse 100 mLs over 10 minutes, right?
right.
Okay.
I get it.
So based off of protocol, if I've had to give more than 1 dose of a bolus dose, that means I need to start an IV drip. If this patient stabilizes, and then I'll put him in the ICU for a good 48 hours, 24 to 48 hours on this drip. So the way the drip works is I have to start at 1 milligram per minute is my order, and my available 900 milligrams in 500 mLs. Okay, I'm mixing my own drips because I'm in the ER. Okay, I don't have the pharmacy involved yet. So, how many vials am I going to need to make 900 milligrams?
Way too many.
A ridiculous amount.
There's 150 milligrams per 3 mLs in a vial.
Oh, you're going to need 6.
6 vials. 900 divided by 150, right? Okay. So that's my available is 900 milligrams and 500 mLs. Okay? 1 milligram per minute. So let's do the math for that. Because I got to set my pump. 1 milligram per 1 minute times 900 milligrams in 500 mLs. Okay? So that's my milliliters per minute so far. We're putting it in a pump. It has to be mLs per hour. So 60 minutes is 1 hour. Minutes cancel out. So now I'm in milliliters per hour. So 500 times 60 divided by 900.
33.3.
33.3 mLs per hour. You know why we always use the same concentrations? I've hung amiodarone enough that I can remember what the starting rate is better than I can the starting dose. I know that I'm going to hang it with 900 milligrams and 500 mLs at 33.3 mLs an hour, just from doing it so many times. Okay, then I always have to really remember what the dose is at 1 milligram per minute. But that is why we do what we do sometimes, because it makes it easy to remember. If I mix this differently, if I put 500 in 500, that would mess up my brain thought process already, right? And I'd have to do some extra math. But we do, the other reason we do the concentrations is based off of studies showing what the vein can tolerate when it comes to the osmolality and of the medication, so it doesn't, or pH of the medications. Okay. Okay, so the order was for 1 milligram per minute for 6 hours. At 6 hours, change to 0.5 milligrams per minute. Okay, so we took our patient to ICU. We're wanting some cross-trained ICU time, so we're going to help and hang out with them for the next 6 hours. In 6 hours, the pump ding's telling us that 6 hours is up. So I got to change the mLs per hour to 0.5 milligrams per minute, 500 mLs per 900 milligrams, 60 minutes per 1 hour. 0.5 times 500 times
Half of
60
Yeah.
equals divided by 900 equals 16.6 on forever. So what is that going to make it?
16.7.
16.7 mLs per hour. Is that exactly half of 33.3?
16.65 is.
Right, but that's not,
Okay.
so it would be 16.7. Right, so we wouldn't just do, we would
round up.
round to the appropriate number. Okay.
Right.
All right, that is a real patient scenario. Okay, so I'm gonna throw this in there, see if you guys can figure this out.
Okay.
How many mLs will I need to infuse for the whole 24 hours?
Oh, for the full, for
How many
the 12-hour shift, or
No, for 24 hours.
Well, you only gave us 6 hours.
6 hours change
And then you change.
for
So you have
18 more
6
hours. Okay,
Okay.
there we go.
Yeah.
Okay, so let's see.
So I'm gonna run it
That's kinda-
6. I'm gonna run it a milligram per minute for 6 hours, and then a half a milligram per minute for 18 hours. What's the total mLs that I'll need?
And that's exactly one from the available.
500.4
mLs.
mLs per 24 hours.
The way it should work is milligram per minute, so 60 milligrams an hour for 6 hours. 60 times 6 plus 30 milligrams an hour for 18 hours. 60 times 6 is 360. 30 times 18 is 540, equaling 900 milligrams, right? And then we know that 900 milligrams is in 500, so 500 mLs. You can do it from the ml side too, but it's a little more accurate. It's a little more accurate to do it from, what's that?
Yeah, we're the 60 and
Can you just go back and?
Okay,
how you got
one more again.
60?
Yeah, just
I had a milligram a minute for 6 hours. Okay, because I would prefer that I figure out in milligrams anyways to figure out how many mLs I would need instead of figuring out doing the ml rate. Because why the ml rate is bad? What did we have to do to these? We had to round them, right? I mean, it gets pretty dang close, but we had to round them. So I would prefer to use something that's exact, and that's the dose, 1 milligram per minute. So 1 milligram per minute equals 60 milligrams per hour, right?
Okay.
Because I'm multiplying minutes
So that's
by 60.
360.
So that's 60 times 6 hours. 60 milligrams, sorry. So 360 milligrams. And then I have 0.5 milligrams a minute, which would be 30 milligrams an hour, because 0.5 times, thank you. I'm all pointing down and not even looking up. So, milligram a minute, 60 is 60 milligrams an hour. I have a 6 hour or dose. Then I have an order for 0.5 milligrams per minute for 18 hours, which is 30 milligrams an hour, because of 0.5 times 60.
But that's not 540, it's
Yes, it is, times 18.
30 times.
You naysayer.
It is 540.
That's not it. Have you done the math yet? Well, no, but I know it's not it. It's not it. Can't be.
Okay.
So, 900 milligrams. So now do we understand why, another reason why we put 900 milligrams and 500 mLs when we
Yes.
start the drip? Because the most commonly ordered time frame for amiodarone drips is 24 hours.
Ah,
So the least amount of times we have to break sterility to spike a new bag or do changes, the better. The least amount is the best. So, kind of cool, huh?
yeah.
That's real life stuff. Stuff that we do in the ICU all the time. But that's the reason why we do 900 and 500. Any other questions? No?
My dad has
Amiodarone? We give it in pill form.
circular, tachycardia.
Does he have a defibrillator? Implanted defibrillator in there?
He can't, he's too far gone now.
Well, they usually do. If they have a ejection fraction of like less than 35%, they'll just put one of those in. It just takes conscious sedation. They don't put it, and then that way, if he does have ventricular tachycardia, this little thing just gives him a jolt and fixes it.
God, I wish they would do that.
So, and let's see, there's atrial tachycardia, which is different. There's not much they do for that other than medications. But
Well, he's so tired from it, and they have to shock him every time.
oh, that's probably some supraventricular tachycardia is different. That's one if he gets tired and is really fast. That's a different one.
He just has to.
Because usually VTAC ends with death.
Well, trust me, he's damn near got there about 20, 30 times.
Okay. If you have questions, come see me this week. The Student Learning Center loves to have people too. I have the hours right here up in front. These purple sheets. So if my times don't work out for you, you can meet with her and she'll actually make appointments too. She's a nursing student. She loves the time. She gets work study hours for it.
So you know I have my,
It's fine to go online and do the thing. Did you do that?
I'm pretty sure I did it all, but
Please, thank you.
I did it like a long time ago. I just didn't print it.